if everything you knew about Earth was wrong? What if we're not on a spinning blue sphere, but standing on a flat disk surrounded by an enormous ice wall? No gravity, no curve, no orbiting satellites, just an endless plain beneath our feet. Could it be possible? Let's examine the claims, not with mockery, but with curiosity. Because today, we're asking the big question: what if the Earth was actually flat? Let's find out using real science. Let's begin with gravity, the force that shapes the universe. Why are all the planets and even large asteroids round? Because gravity pulls matter inward equally from all directions. It smooths out edges. It forms spheres. In 2023 and 2024, NASA's James Webb Space Telescope captured distant planets still forming. And even in their earliest stages, they were already becoming spherical. Now, imagine Earth as a flat disk. Gravity would pull objects toward the center of the disk, not straight down. That means oceans would slope inward. Water would flow toward the middle and away from the edges. Imagine trying to sail uphill across an ocean. Clearly, that's not happening on our planet. Some flat Earth models claim gravity doesn't exist at all. Instead, they suggest Earth is moving upward, constantly accelerating at 9.8 meters per second squared. But if that were true, we'd see something called time dilation, the effect astronauts experience when traveling at high speeds. We don't observe that here. And without gravity, Earth couldn't hold on to an atmosphere. A 2023 study from the University of Tokyo showed that stable weather systems, the kind that spin and move across our skies, require a spherical planet. On a flat Earth, storms wouldn't spiral. They'd collapse outward. There'd be no air pressure, no clouds, no flight, no breathable sky. Without gravity, none of this works. Many flat Earth believers say the oceans are contained by a massive ice wall, commonly referred to as Antarctica. But science tells a different story. In 2024, the Cryosat-2 satellite mapped deep undersea canyons beneath Antarctica. These canyons are formed by tectonic plate activity, movement only possible on a spherical Earth. Meanwhile, Argo float satellites have shown how tides around the world are influenced by the moon's gravity. This tidal movement is consistent, measurable, and it aligns with the physics of a globe. Every time you check a tide chart before visiting the beach, you're using globe-based science. So, what about day and night? Flat Earth models often depict the sun as a small spotlight, rotating above the disk. But in 2023, the Solar Orbiter captured ultra-high-resolution video of the sun, revealing enormous solar flares and magnetic loops. These flares interact with Earth's magnetic field, triggering auroras near the poles, a phenomenon only possible with a spinning, molten planetary core. A flat Earth doesn't explain this. And then there are eclipses. During the total solar eclipse of 2024, scientists observed the Baily's beads effect. Beams of sunlight passing through valleys on the moon's surface. This can only occur if the moon is a spherical object, precisely aligned between the Earth and the sun. Flat Earth models fail to explain these basic celestial events. So, if the science is so clear, Why do some people still believe the Earth is flat? Psychologists call it motivated reasoning, where individuals adopt beliefs that align with their worldview, regardless of evidence. And in recent years, this has become even more complicated. In 2025, a series of AI-generated confessions from supposed astronauts went viral. Highly realistic, completely fabricated. Thanks to deepfakes, it's now easier than ever to blur the line between truth and illusion. And when misinformation is wrapped in dramatic music and convincing visuals, it can be hard to separate science from story. If the Earth were flat, there would be no gravity, no stable atmosphere, no magnetic field, no tides, no satellites, and no climate as we know it. But because of centuries of observation, experimentation, and technological advancement, we know our Earth is round and wonderfully complex. So, next time someone questions that, don't argue. Ask questions, share evidence, let curiosity lead the way. Thanks for watching. Like, share, and follow for more science. Explained simply. See you in the next video.